Hey, Mr. Worst here. Hey, I'm gonna go over binary to decimal conversion. So you have, look at that, this Google form here. So you have some binary quantities, base 2 quantities, robot math quantities, and you need to convert them into decimal. So like how we as humans normally count, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, stuff like that. And binary is like 0, 1, 1, 1, 1, 1, 0, 0, 0, 0, 1, 1, 1. Okay, Mr. Orr, stop trying to be funny. So let me kind of walk you through that. So last class, we talked about this, and but maybe, sometimes it takes longer than one time to get something. So the first place is worth 2 to the 0 power. 2 to the 0 power. Second place is worth 2 to the 1 power. This is in binary. Third place is 2 to the 2 power. And the fourth place is 2 to the 3 power. A better way to think of this, I think, because this gets kind of like a lot to think about, is you just start with 1 and each place doubles. Okay, so let me erase that. So, or maybe I'll just draw it over. So first place is 1, next place is worth 2, next place is worth 4, next place is worth 8. Okay, so 2 to the 0 power is 1, 2 to the 1 power is 2, 2 to the 2 power is 4, 2 to the 3 power is 8. So you just start with 1 and then each place value doubles. Unlike decimal math where you go up by powers of 10. So 10 to the 0 is 1. So you got the ones place, the tens place, the hundreds place, the thousands place, etc. This is, it's shorter actually, but it gets a little bit complicated. Okay, so let me erase. Let's undo a bunch of this stuff. Can I undo? Oh, it's not going to let me undo. Oh, it is going to let me undo. Okay, sweet. So let's undo all that complicated stuff. So instead of, let's just think of it like this is the ones place, this is the twos place, this is the fours place, this is the eights place. Make it as simple as possible. Okay, so what we want to do is we want to convert from binary to decimal. Okay, so in binary, say like we're given the binary number like this, 0, 1, 0, 0. And the way you sometimes tell that's in binary is they'll have base 2. So in parentheses 2 is a subscript. What would that be in base 10? Normal human counting, base 10. Okay, and we just look up here. Let's use a little laser tool. So the only bit, keyword from last class, only bit that's turned on is the 4-bit. So we have 0 plus 4 plus 0 plus 0 in decimal. That's going to be 4. So 0, 1, 0, 0 in binary is 4 decimal. Okay, you're going to do a bunch of calculations like that. Where it gets tricky is when you add bits together. So for example, if you have 0 or 1, 0, 0, 1, okay, in binary, what is that in decimal? Over here, what would that be in decimal? Base 10. Okay, so let's use the laser tool. So the 8-bit is turned on and the first bit, bit 1. Okay, so the bit that's worth 8 is on and the bit that's worth 1 is on. So 8 plus 1, 8 plus 1 is 9. Voila! Okay, so there's a Google form where you're going to answer a bunch of these. Okay, you'll see the options go 1 down to 15 because the most you can make with 4 bits of data is 15. So yeah, I hope that's doable. I'm going to post this video right up here at the top so you can watch it for like some review. Okay, cool. And you can submit the more forms as many times as possible. But since there's so many options here, because you don't want to just guess and check. That would take you way more time than actually just learning it. Okay, but you'll get immediate feedback on whether or not your answer is right or wrong. See you in the next act.